Hello everyone, thanks folks for coming. As I was presented already, we'll present about library called Repid. So let's start with a quick introduction about me. I'm Aleksandr Sulimov. You can call me Alex for short, or you can find me by at Alexu on the internet, on GitHub, or whatever. I'm Python backend developer. A few fun facts about me. I started to learn Python when it was version 3.4, the latest one. So I've checked it out. It would have been 8 years ago or something. So it's crazy. I did a lot of embedded hardware and software engineering after that. So not all of that experience has been in Python. But eventually I came back to Python when Asyncio started to gain more popularity because I wanted to learn it and utilize it. So I have a quick question for the audience. How many of you guys use some sort of queues in your application? Okay, so it's around 50-50. Cool. So for those who don't use it yet, please treat this talk as an encouragement to begin practicing in this topic and queue up your questions, pun intended, and let's start. So let's look at existing solutions and something like Celery, which is very popular in queuing. Yeah, that's the simplest example ever. Of course, when we want to do something real, things get more complicated. So this is not such a trivial task. We do a call to pycon.lt. For example, I imagine this is some API. We get a response, we perform some cacheable operation with the data we received, we store it to the database. So there is one commonality with these queries or function calls, is you started to wonder, does my process really have to wait for all those operations to complete? And in fact, all of these operations are IO bounded, right? So Asyncio to the rescue. So first of all, let's start by modifying our function to be async def. So it will be a coroutine. And then let's modify our actual function calls. So instead of request.get, we will use HTTPX library, for example. This is a pseudocode, so don't query me on it. Don't quote me, sorry. And we await everything. Yeah. We modified our implementation somewhere else. Now it's async. So it would have been great if it would have been that easy. But in fact, there is a catch. So there are two most popular libraries, Celery and Romantic. And the catch is they don't support Asyncio. Neither of those. And that's where Repid comes in. Repid is a task processing library written with the idea of Asyncio being the first-class citizen. So let's talk about Repid and a few key points. First comment was on October 24th, 2021. It supports RabbitMQ and Redis as the backends, but you have a possibility to extend and introduce your own backends. The name comes from Redis RapidQ, but it's not only Redis, as you can see right now. It supports Python 3.8 plus. It's 100% pure non-compiled Python, which will allow you to use it, for example, with Pyodide, which we will talk about a bit later. It has 100% code coverage and battle tested in production. Doesn't have any required dependencies. You can use it on their own, and it's fully typed. So you will have editor auto-completion when you work with it, and you can use MyPy very easily with it. So let's turn our previous example to an example with Repid. And it's very simplistic. You just create Repid router, and you use router detector to declare your function. That's basically it. It's not much of a change. But instead, underlying logic fully supports async. And I want to do an interaction with you folks. So please scan the QR code. It will take you to the URL below. It's Repid's documentation, but it will load an example for you of Repid running on Pyodide. We will discuss a simple app further. Everyone's done? Or I need to return the slide? Yeah, cool. So here's a very simple app. It's similar to what you see in the playground. Basically, we can divide it in 4 parts. You have initialization, consumer, producer, and a worker, which is called running the consumer here for the sake of simplicity. So the code is probably too small, so let's take another slide which will show it better for you. Here you have dummy broker. So you initialize a Repid app with connection with the dummy message broker. You create a router as I showed you earlier. You decorate some function, whatever you would like. But please remember the exact name of this function and its arguments. It will be important in the next slide. So here is our producer and our worker. So our producer part, you create a job on the line 3. In the job, you will have to specify the name of the function. That's how it will map your job to the actual actor on the worker. So specify the name of the function, and you are able to specify also the arguments as well. Then I declare a queue explicitly here, and I enqueue the message in that queue for the job to be processed. To actually process the job, I create a worker where I specify the router which we created earlier and to which we assigned our actor. And I specify messages limit equals 1, so just our worker won't run endlessly. It will only process the message which we enqueued and will exit. And then I run the worker. So it's very simple. It's almost the same as you see on the Pycon in the web. So by the way, you're able to modify it there. If you want, you can play around with it. So let's talk about what is present in Repid, but doesn't distinguish it from other libraries, so very quickly. We have auto retries with ability to specify custom retry policies. So if your actor fails, you'll be able to tell it how many times it should retry and what is the delay between retries by specifying a retry policy function. We have a reliable delivery. So what it does mean is that if for some reason your worker fails or electricity cuts off, whatever, your message will stay in the message broker. It will not be lost ever by design. We have prioritization, so we're able to query messages in the same queue but with different priorities to be processed by the worker in the preferred order. We have deferred task scheduling. You can schedule a task to be processed at some point of time, defer by some portion of time. So for example, you can defer by, let's say, 12 hours, so it will execute every 12 hours, and we also have cron, so we will be able to say, okay, let's run this task every Monday at 12, or something like that. We have support for storing arguments and resultant separate storages, so you won't have to overload your message broker with endless amounts of information. You can store it in, for example, Redis, and just put an ID automatically inside of your message broker, and then it will go and query the needed data before executing your actor. And we have in-memory broker support, as I've showed you with the dummy, and you may see on the playground, for mostly testing purposes, and so you don't have to run any message broker to play around. We have also a thing which I call proper routing. So here is an example of a distributed system of event-driven architecture. And we have a queue and a couple of workers. 2 of those are version 1 and another one is version 2. And let me explain it. So imagine enqueuing a message with a version 2, but you don't control to which worker it will be actually distributed. So if it will be distributed to the first worker, which is version 1, as we can see, this worker won't accept it. It will pass it to the next worker, and eventually it will go up to the last one, which can process it. in practice, it looks like this. So let's imagine we have this function, which I showed you earlier, and we want to do some modifications to it or something. What we can do is simply rename the function, so that we will have this version 2 tag in the name, or we can override the name in actor. In the actor. Let's talk about performance. So, first of all, as you can see on the graph already, Repid comes first, but let's discuss it a bit. So I've tested especially I/O bounded performance. So the task was to increment a field in Redis and sleep for 1 second. So imitating I/O bounded operation. And obviously, if you do this simple work, you can use something called green threads. So in case of dramatic, it's called event. In case of celery, it's called eventlet. It's different libraries. But the thing is that they use monkey patching to offload I/O-bounded operations off your CPU. But you can do the same thing essentially if you use async I/O, and you won't have to use monkey patching, so it will be much more stable and you will be able to use it in production. And if you do not use these green threads, difference becomes very obvious. It's like 1,000 times difference, so it's much faster in I/O bounded, especially. So another cool feature, you are able to use custom middlewares. So here's an example of Asyncio middleware. It will run after your actor, as the name suggests, and we will report an exception, for example, if one was catched inside of your actor. But you're also able to use middlewares with other parts of your brokers. So here's an example which will be executed after a message was not acknowledged, so NAC. It will log error, produce a log of type error, sorry, that message was NAC'd. Let's talk a bit about future ideas. Here's the QR code that you can scan, and it will bring you to the Repid GitHub repo. You can place a star there. I would really appreciate that. So, upcoming features. I would like to support a simple web server so that you won't have to do anything for Kubernetes live checks. I would like to generate async API schema automatically from your function, from your actor definitions. So essentially it's the same thing as Fast API does for your Open API schema, but Async API is for event-driven systems. I would like to make workers communicate with each other so that you will have support for task cancellation and some on-the-fly changes. And also include PyTest features so that you will be able to test much easier than it is right now. Tighter integration with Pydantic so that when you declare an actor, your schema definition can be enforced. And auto-routes generator for Fast API so that you won't have to say, okay, here's a route to enqueue my message and here's a route to retrieve a result of my message. You will be able just to generate it with one line. So that's it from me. Sorry for the quick run. I thought we are bad because of the presentation issues.